Unity with Nottorus, Hex and Tile Grids Part 1. We're going to go ahead and create a procedurally generated grid, be it hexes or cubes, and we're going to be using Nottorus Visual scripting. So the first thing we want to do is go ahead and create an empty game object. This will be our game manager. So I had one created, but I just deleted it. I'll call it board manager, and there we go. So the next thing we're going to do is open Nottorus Visual scripting and start creating a game board. Call this something like game board manager. There we go. So I usually select a namespace, so in case I use a generic method, it doesn't conflict with anything. So, you know, I suggest you probably do the same thing. So, namespace up there. We won't need the update, so go ahead and remove the update. And then I usually compile at this point, so I start with a generic file. What I'm going to try and do is bring it up on the same screen so we can see the code as we do the visual scripting at the same time. So get the inspector over here on the right hand side, and then we can lock it, and then the code will be displayed each time we compile the visual scripting method. Alright, so let's get started by creating some public variables that we're going to know we're going to need. Things like the tile height, tile width, the game board width, things like that. So here's the first one: is the tile game object. This could be a a cube or a hex. We'll write code to make that work later. We're gonna need to know the tile width of the width of the game board. So in tiles. So we'll set that up. Basically grid width in tiles, grid height in tiles. And then we're going to go ahead and do the tile width and tile height as well. So we're going to make the floats for the tile width and tile height. They will be integers. And the top one's a game object. Given that we're going to use hexes or cubes, we will need a boolean here to make that decision for us. So, is it a hex or is hex? And what we're going to do is add some attributes, header attributes and tooltip attributes, so that within the inspector, when we see it or somebody else sees it, they'll know what to actually do with it, what it's for. So we'll put a hover over tooltip. You know, is this a text tile, or check mark if it's a hex or something like that. Header as well. A header and a tooltip. So one is a hover over, one is the header. I usually try to do both of them for variables that are questionable. Other thing we're going to want to do is create, is it a pointy hex or a flat topped hex? So we will need to deal with that later. So, and they'll be handled slightly differently. So we'll have some logic a little bit later to make that selection. So we'll put a boolean here for is pointy hex, yes or no. And we'll put a hover over for that as well. OCD's getting to me here. I have to make them consistent, I guess. So now let's go ahead and start creating some methods. We know we're going to need a number of methods to make this work. So the first method we're going to probably need is setting the tile size, setting the tile gap, which is a gap between the tiles themselves, calculate the start position, calculate the world position, and then we'll go ahead and create the grid. So those are some of the initial methods that we're going to go ahead and create. So there we go. Set tile size, set tile gap, calculate initial position, and calculate world coordinates. And the last one will be create grid. Go ahead and the file and just pop it over there and check out the code to make sure it's looking okay. It is. Good. We'll start with the start method. So the first thing we're going to want to do is make sure that we're setting the tile size and the gap. So those will be the first two that we call. So we'll calculate the tile size and then we'll add a gap to that. Here we're going to put some error checking in to make sure that the tile game object is set, because if it's not set, the whole thing falls apart. So, just to make sure that we have a little bit of game, error correction, error code logic in here, just to make sure things are set correctly with the inspector before we, or as we could play, at least it'll be easily identifiable on what the problem is. So if the tile game object itself is null, we will just send something log warning or log message to the console. You can see I had it as a favorite, but debug.log you can type in as well. Descriptive here because once the game gets a little flushed out, it's hard to find stuff like that, so I usually try to be specific. Once we validate that, we can go ahead and create the grid. So let's there we go. It's our start method at this point. Next thing we want to do is maybe either the gap or the size. I guess it doesn't matter, but we'll squeeze the gap in here first because it's a little bit easier to do. And then what we're going to do is use bounds for the size. So that'll be nice, so we won't have to actually have a specific size of hex that we need. We can actually calculate those bounds and go from there. So first thing we want to do is we're going to get the tile width and tile height. We're going to add a tile gap, global public variable, and then add those together just to add that tile gap. So if we want like a 1 metric unit of gap between the tiles, or no gap, or give us some options there. Just add them together, just adding that tile gap into the tile width and tile height values, variables. So pretty straightforward. There we go. We just added a gap in there. What we're going to do is do the set tile sizes. This is where we're going to calculate the bounds of the tile itself, the X and, or the X and Z. So feed the tile width, tile height, tile width, tile height in order like that, can be consistent. Do is basically the tile game object, be it a cube or a hex, is fine. What we're going to do is get the component of that tile object in this mesh renderer, and the mesh renderer has a bounds option, so it's able to calculate the bounds of the mesh render. So we get the size of that, and we can feed that into, it gets a vector 3, so we can get the x value of that and feed that into the tile width. And we're going to do exactly the same thing with the tile height, but we're going to use the z value instead of the x value. Now we just found the size of the tile itself. Tile size is ran first, so just move that around. Tile gap. Now we'll go ahead and work on calculating the initial position. Basically the start position. What we're trying to do is center the map at 0, so everything's really just centered correctly as well. So there'll probably be some massaging of the logic here as we go along, but that is the initial goal, is to try and get it centered at 0 and create the grid. So I suspect this logic will be incorrect initially, but we'll play around with it and see how that works out. So what we're going to try and do here is get the start position. So we're going to do some calculations and feed these calculations into the vector 3 of that start position we created, the local variable. You obviously see what I'm doing here. Just getting some logic here to feed into that start position. I don't think I really need to narrate adding the math in here. We do want to use a vector 3. We have an option of using a vector 2 as well, but given that we're only really using the x and z axes, but we want to do an offset of the y at some point to either raise or lower the grid map. We're going to go ahead and leave the y at 0 at this point, and if we do want to increase the height of the map, we can deal with that later, and leaving the y at 0 at this point. We can come back and modify that to 1 or -1 if we wanted to up or lower that tile map itself. It gives us some opportunity later to play around with that. If we started with vector 2, we wouldn't have that option. It'd always be at 0. So now we've done with the X, we're going to go ahead and finish up with the Z here. So we got the tile width, the grid width and tiles up above, and now this is the grid height and tiles. Code for that as well, so that's coming along nicely. Yeah, we may have to come back and massage this a little bit, but this should get us kind of started, at least a framework going. Now we want to go ahead and start with just create the grid. We'll come back to calculating our world coordinates here in a bit, but we'll get the grid going here. So the first thing we want to do is get the tile grid game object. This will be the actual tile manager or game board manager itself. Tile in the grid position. So this one's going to be a vector 3, and this one will be game object, and the next one will be a game object as well. Setting up the game board manager game object that we created earlier. We're feeding that into, we're grabbing that and feeding that into this tile grid game object local variable. What we're going to do is parent everything to the game manager empty game object, so all the tile objects are underneath it and stuff like that. So we just want to grab that temporarily, and then we'll do some parenting naming and stuff like that. Here's where we create our for loops to start iterating through the locations, tiles, etc. So what we're going to do is initiate that tile, or instantiate that tile, sorry. That should instantiate a tile game object in the for loop, so we'll start iterating through that and create a grid for us. set the position. Here what we're going to need to do is we're setting the position, but we want to calculate the world coordinates in that position. So we're going to have to add an input value here for calculate world position. So it'll take the grid position, right? So it's going to be a vector 3. It's going to take a vector 3, and actually it's going to receive or return a vector 3 as well. So we'll have to change that. I know I selected vector 2 there, but we'll come back and change that to a vector 3 in a second. You'll see what I'm doing here. So we're going to grab that. Oh, I forgot to do the return value as well. So let's fix that real quick. We'll get the return value. See, there's no connection out to the position. So go over here and add that return value down below, and that's vector 3 as well. What we want to do is connect these so it can actually compile without it throwing an error. So we'll just connect this and select new for now, but we will come back and modify that. And we are now able to take the grid position, throw in the calculate world coordinates to the current position of the tile, and that should set it correctly. Next thing we want to probably do here is parent the tile to the grid game board manager, so everything's not in the root of the hierarchy. There we go. So that should parent it. Parented to the game. There we go. Oh, we forgot the grid position. We'll have to feed that grid position in from the loop, from each of the 4 loops. So we're going to select new, and then we're going to feed that X and Z values into that grid position. But notice how I selected a vector 2 before, and this will actually need to be a vector 3. So we'll get that fixed. But notice how we're going to feed that value into the X and Y. So over here we'll have to change that to a vector 3 like I mentioned earlier. Now we can actually feed that into the Z value instead of the Y value. Y value at 0 like I mentioned earlier, so we can either increase or lower the height of the entire grid or individual tiles later on if we so desire. So I think that finishes the calculating the create grid piece of it. Next and last method here we have to do to kind of get the basic framework together is calculating the world coordinates. So let's go ahead and start that. We'll create a local variable called initial position. Now notice in local variables they can't have duplicate names. In C# they typically can. If they're local values, they can have the same name as other local values as long as they're not impacting each other or anything like that. But in Nottorus you can't do that. So you'll notice that I'll have to do initial pos or initial position 1 or x1, x2, x3 because I can't use the same names as other local variables. Just be aware that's why I'm using, like right here, x1 instead of just x. So creating an offset, initial position, x1 and z1. Offset's a float. X1 and x2 will both be floats as well, and then initial position, of course, is a vector 3. So we'll grab the calculate initial position and feed that into the init position of the local variable. We'll set the offset to 0. Basically is math, seeing if there's a return, like a carryover of doing the division. It's called mod, but it's basically the adjustment for the hex map and being able to put that offset in so that the hex map is offset for each line. Offset to the tile width. We may have to come back and modify some of the math here, but overall, we're just trying to get the framework set so we get the grids created, and then we'll probably have to come back and either fix how they're positioned or something. We'll at least get the framework splatted down here and see what we do. Now obviously I could just feed that x1, x2 that were already out there directly over, but sometimes I like just using the x1 independently like that, so just in case I add more code in later, I don't have to worry about it changing values. I just feel more comfortable doing it that way sometimes. Now here we're just doing some math to calculate the position of the hexes or tiles. In this particular case it would be hexes because we're doing the offset and stuff. But what we'll do later on is put an if statement in, if hex, and then we'll go a different direction if it's a cube. But this is for the hex specifically. So there's just the basic math of getting the grid set up correctly, the initial position of the grid, and then the world coordinates of each tile of the grid as it cycles through 4 statements, 4 loops. gotta see how it works here. If we're gonna set our grid, we'll add the script to it. We'll select it to be maybe a smaller grid, 5x5 grid with pointy hex. So we'll select pointy and just hex, even though we don't have some of that logic in there. It doesn't matter. Oh, I need to modify something here. It needs to be 5x5, and then what we also want to do is make the tile height and tile width private. We don't need to make that public because it is auto calculated for us. So we don't have to specify it's a 2 size hex or a 4 size hex. It should just measure it for us. We don't need to see that information in the inspector. Great, that is a hex map. Awesome. So I think we need to work on centering it, but overall that's it. Thank you very much.